we move on from page 8. So here we are talking about breaking down a force into two components. Breaking down a force into two components, P and Q. And of course, we have infinite number of combinations, and we will talk about these two cases, especially this one. So we work on the problem 2.1 again, and this is problem 2.1, right? This is problem 2.1, and we look at this again. So here in this problem, we want to add what are we determining in this? What do we determine here? We determine the resultant of P and Q, right? Here we determine the resultant of P and Q. Now of course, we work on the same problem, but we use a different method. Sorry. Here we use a different method, okay? We use a different method to determine the resultant of P and Q. Now, we still need to draw the diagram. We draw the diagram again here, and this is P and this is Q. And the resultant here, R, is here. Okay? And this one is 20 degrees, and this one is 25 degrees, and of course, and let's say we don't know the angle over here. Right? This one is equal to 40 Newton, and this one Q is sorry. I write it here. Q equal to 60 Newton. It's okay. Now we don't. Last time we deal with the angles in this triangle, and we deal with the angles in this triangle, and determine alpha and determine the size of the length of the size of the triangle. But this time we do it differently. We use a different method this time. Now we break this force Q into two components. We draw it like this, and here and here. Okay, this one we just say Q parallel and Q perpendicular, and this one is 90 degrees. These two have the same. Direction. Okay. This one and this one have the same direction. And this one and this one has 90 degrees. Okay. we write, of course, at first we have Q and we draw it like Q parallel and Q perpendicular. Okay. From here, what do we have? What do we know? We are having R is equal to P plus Q, right? Of course, we want to determine R. R is equal to P plus Q. But now, if we write it like this, then what do we have? We have R equals to P plus Q parallel plus Q perpendicular. Is that okay? Is it logical? Is it okay? Why do we do this? Because this one and this one they have this one and this one are in the same direction. That we can add them easily. We can add P and Q parallel easily, and that this one and this one can be added by trigonometry. So something. Now, if you're okay with that, I move slowly. That you can still draw the diagram. So we need to know P is equal to P is 40 Newton. So the next thing we want to know is what are the forces, how large, or what are the magnitudes of Q parallel and Q perpendicular. Q perpendicular, let's have a Q parallel first. Q parallel is equal to cosine, 60 times cosine 25 degrees equal to 54.38 newtons. And Q perpendicular is equal to 60 times sine 25 degrees equal to 25.36 newton. No, and I think you know why we write like this, right? So because this is 60 and this is a right angle triangle, and then we have cosine and sine. Now, how do we calculate R? R is equal to square root of P plus Q parallel square plus Q perpendicular square. Right, because these two are 90 degrees to each other, right? Perpendicular to each other. So the next step would be just put in numbers, and we will arrive in. Sorry, that is I should not put the vector sign. So this one is equal to 97.73 Newton. And the angle alpha will be, I'll give you time after this to write it down, okay? Arctangent and 25.36 divided by 54.38. This is what's the angle? 15.04. No. We say this as in English we say this arctangent. 就是反的 tangent 是英文是 arctangent。Now, if you are okay that with this, then I'll give you some time to write it down, okay? Anything unclear from anything unclear or sound looks a bit strange here. Right, thank you. And this is 94, right? Yeah, thank you. Yeah, 94, sorry, it should be 94.38. Thank you. Yeah. Because this one is 54.38 and this one is 40. Yeah. So it should be 94. Okay. Thanks for the reminder. And so of course we can get R here is equal to of course, the answer is the same as we did it last time, but we use a different method to work on the same problem. Okay. So take your time to write it down. Of course, it will be on the video, but I usually give time to you to write them down. Okay. Now I will go to okay, so I assume I see wait a minute, I don't want to write. Yeah, Then we go to the next page. And now we have, so we know we can break a force into break down into two components. So we now have say we have the force F here, and we can of course if we put on if we have an x direction and we have a y direction, we will have we can break this force down into Fx and Fy. Okay, we can break this force down into Fx and Fy, and we mark an angle theta here. And of course, I assume you have done this before, and just to have let's have a revision here and look at it again. And this one is Cartesian coordinates, okay? Coordinates， 它是坐标嘛 ？Cartesian coordinates. So I assume you know the word, but in Chinese, so I just repeat it in English. Here, of course, we have you can first draw it, and then I will go on. Now we have f here is equal to fx plus fy. And we have the magnitude of fx is equal to f cosine theta, and magnitude of fy is equal to f sine theta. Remember the difference between this one and this one. And fx is a vector, is a force, it is a vector. And fx we found the arrow is equal to magnitude of fx, okay? So with this arrow and without this arrow, then there is a difference between this one and this one. So if there is a arrow x here, then it means this is a vector. It has a magnitude and it has a direction. Okay. For the one below, then it means the magnitude of fx, which is a actually this is a scale. So now, of course, that because we all know that x is horizontal and y is vertical, so we want to rewrite this and make it easier to understand. Okay, make it easier to understand. So we talk about we introduce a thing called unit vector. Unit vector. The definition of unit vector is unit vectors means the unit vector means its magnitude is equal to 1. So we in using vectors, that we have unit vectors. That the unit vectors, that means the magnitude of a unit vector is equal to 1. And in the x and y, I'm not sure whether you use unit vectors before, and of course we have x and y directions, and so if we talk about unit vectors in x and y directions, so I think, did you use I and j here before in high school? I and j, yes, okay, good. And some teachers would like to use the I hat and j hats to show that they are unit vectors, but it is okay to use this one or this one, but I and j. So these are unit vectors. It means their magnitudes are equal to 1. Their magnitudes are equal to 1. Okay. Now, if we have because we have f equals to fx plus fy before, right? F is equal to fx plus fy above. I'm just repeating it. So we can write the magnitude and direction using unit vector. So we have fx I plus fy j here. So now we talk about unit vectors. Unit vectors are vectors with length of 1. With this, we can write fx as a vector, and then we write the magnitude of fx as fx, and the direction of fx we can simply write I. Magnitude, of course, we need the magnitude. We need the length of the force. But and then to mark the direction, we use a unit vector to give us the direction. This is to the x direction, right? I is to the x direction. And to the y direction, we have j here. It's okay. Now, so if it looks okay, at least, and if it looks okay, then we go on to this example 1 here. So here we have a force of 800 Newton exerted on x. It means x1. And both A as shown here. And determine the horizontal and vertical components of the force. So what's the Chinese of horizontal? I'm not. I think I have mentioned in the video. So, okay, very good. And vertical. Yeah, very good. And so this is horizontal and vertical. Okay. So I think this should be easy to use, and the only the only the only problem is here we go. For example, if we have x direction here and y direction here, and the force goes this way, right? And because in we usually write x is positive to the right. This one is plus 1x, and this one is plus 2x, and this one is minus 1x and minus 2x. So to determine the angle, remember that. Sorry, I'll come back. I'll come back in a second. And remember in here that we have the angle theta goes from here in this direction. So what is the angle of this force? This is not equal to 35 degrees, but this one. Okay, because we usually have x direction is to the right as positive, and then so when we determine the angle, it should go this one and then go this way. And this way this way is I'm not sure if I mentioned in the video, and it is counterclockwise, CCW. So this one, in this one, that we need to consider the angle is 145 degrees. Okay. This is counterclockwise, or somebody would simply say anti-clockwise. There are two ways of saying this. But the short form is always CCW. So the horizontal and vertical components of the force are these two. Once you remember that it is 145 degrees, I think you will get the other things right. Okay. Or we will say f is equal to fxi plus fyj is equal to this one. Okay. I think this should not be a problem to you. Let me take a short break here and